that it makes up 99.99% of the visible universe. So our inexperience with it on the Earth's surface is rather crippling when it comes to trying to decide on a cosmology to explain the visible universe. Now, plasma behaves rather oddly compared to normal matter, the matter we find, the solids, liquids and gases on Earth. If you look at a novelty plasma ball, you will see that it forms these bright filaments that dart all around inside the globe. And if you look closely at them, you'll see that they're actually twin filaments twisted together. In other words, nature finds it efficient to be able to transfer energy over a distance by twisting two pairs of filaments together. And this is a characteristic of the way plasma carries electric currents in space. And one of the puzzles that has faced astronomers since the space age is the discovery of filamentary structures in galaxies, around stars, even the cometary tails of planets and comets themselves. These filamentary structures have come as a surprise. We now have plasma physicists who are doing important experiments in laboratories around the world, and one of the virtues of plasma experiments is that they can be scaled over an enormous number of magnitudes. In other words, a discharge phenomenon that may be seen in the laboratory that occupies only a few centimetres can be scaled up to the size of a galaxy, and you will see the same structures. Now, this introduces a new area into cosmology where we can do experiments on Earth which can verify our ideas, our theories about how the rest of the universe works.
Some of the natural consequences of electrocosmology are the patterns that we see, both in the laboratory and in the sky. A very good example of this is the work of Dr. Anthony Peratt, who was a graduate student of the very famous Hannes Alfvén, who was really the father of electric cosmology. Peratt simulated on a supercomputer using just a cloud of electrical charges and a magnetic field, just using the laws of electrical science, not using anything to do with gravity. He simulated what looked like a spiral galaxy. And the interesting thing is that Peratt's spiral galaxy in the laboratory had exactly the same rotational properties as the real spiral galaxies that we see in the sky do.
Plasma was named by Irving Langmuir because of its lifelike qualities. In other words, the similarity to blood plasma gave rise to the term plasma now used in the sciences. Well, this has incredible meaning for us because of the nature of the metamorphosing. The god who is now an eagle, now a serpent or dragon, now a leonine figure with long flowing hair. These figures take on a whole new meaning when we can interpret them with the benefit of plasma science.
The new instrumentation that was developed in the space age expanded our ability to perceive things, perceive facts. We could now see things in the entire electromagnetic spectrum instead of just the narrow sliver of visible light.
What you're seeing is the actual moment of deploy there when we take the switch to deploy, and it's so quiet.
And we had sensors that were out in space. We were freed from the geocentric and anthropocentric order that had prevailed before. Got a whole new universe, and theoreticians are still trying to look at it through, a friend of mine says they're peering through the wrong end of the telescope and trying and telling us what they imagine they see.
Modern cosmology gives us a rather disconnected view of the universe. In other words, we are separated star from star by vast distances. Light takes a long time to travel between stars and across galaxies, and therefore we look upon ourselves as isolated and disconnected. The electric universe takes a different view. It says that we are a part of the sun's environment, electrical environment, and the sun is a part of the galactic environment, and the galaxy itself is strung, like all galaxies, on huge electric currents flowing through the universe.
One of the typical questions that plasma cosmologists hear all the time is, how do you know what's out there in space? How do you know there's electricity out there in space? Is there energy out there in space? Why should we consider anything more than gravity? And the answer is that through the years, we've used optical telescopes, but recently we have what are called radio telescopes, and we've broadened the spectrum that we can look at the sky with. And those radio telescopes can measure electric currents and magnetic fields, and we can determine from those measurements the strength of the electric currents, the strength of the forces involved, and the amount of energy that's stored out there in space.
The two major pillars of modern cosmology are based on the theories of relativity and quantum theory, and yet, as Einstein himself noted, the two are incompatible. And that may be because the theories of relativity deal with matter as if its only consequence is the bending of space. The electric universe, on the other hand, deals with the electrical structure of matter at the subatomic level and then works its way up through living systems, if you like, planets, stars, galaxies, and the entire universe, and shows that it is the electrical structure of matter that forms the amazing shapes we see in deep space. We can demonstrate the existence of these currents flowing between galaxies and between stars by the presence of the magnetic fields they generate. Magnetic fields are threaded through space at all dimensions, within the solar system, on the surface of the sun, between stars, and within galaxies, and even between galaxies. Now, a magnetic field can only be generated by electric currents. So, in other words, to continue that magnetic field for any length of time requires that there be electrical power input into those magnetic fields. And that raises the whole question of where does this power come from?
Modern cosmology is highly mathematical. In fact, we were joking before about the idea that the only people who understand cosmology are professional cosmologists. The basis of cosmology, really, if you hunt for it, lies in Einsteinian relativistic mechanics. And when Einstein promulgated his ideas, he totally and completely ignored anything electrical. And so the modern cosmology, with all of its ideas of omega and expanding universe and inflation theory and the Big Bang and all the rest of it, are predicated on a foundation which ignores almost half of man's knowledge about the way the universe works, which is electricity.
It may sound like I'm dismissing Einstein and his theories of relativity out of hand, but we have to give Einstein credit for his integrity in pointing out that his theory did not meet his requirements, and that is that his theory had to be tied back to some form of reality. And there is no explanation as to why matter should curve space to give the effect of gravity. He felt that quantum theory, being a probabilistic theory, divorced cause and effect. And this is one of the things you cannot do in physics, is divorce cause and effect. Otherwise, you might as well give up and get a real job. But this is a puzzle that dogged Einstein through his later years, to the point that his followers tended to go off and use his geometrical explanations to conjure up things like black holes and neutron stars and so on, and the expansion of the universe and the Big Bang, without referring back to Einstein, who, with great integrity, said he wasn't satisfied with his explanation. One of the problems faced by astronomers after the space age began was to explain the discovery of very concentrated outbursts of energy in deep space. And that meant for them, since gravity is the only driving force available to them, that they required an infinite concentration of mass, because gravity is an infinitely weak force.
The black hole, as Wheeler originally visualized it, sucked everything, including light, in, and so therefore it was invisible. So he could postulate its existence, and we couldn't see it. And because we couldn't see it, we couldn't prove that it wasn't there. Later on, in order to explain these fantastic emissions of energy from galaxies, it was proposed, and I believe it was Stephen Hawking who did it, that there were various types of black holes, some of which actually then spat matter back out again in jets. Because, why? Because we had observed jets.
In the electrical model, it's quite simple. If you think about it, the power that's expressed in your own home, in the heaters and the electric motors and the lighting and so on, is actually generated at a vast distance away from your house. In deep space, the same thing is true. The energy which we see concentrated in these events which are attributed to black holes and so on can more easily be explained as the confluence of electric energy from different parts of the same galaxy or even from other parts of the universe. And it is this explosive release of energy which forms the vast jets that we see lit up and exploding from the centers of active galaxies.
We also have observed double radio sources either side of galaxies. And that event was predicted by Hannes Alfvén, the founding father of modern electrical cosmology, and is still to this day unexplained by standard cosmology. One of the most interesting phenomena in the sky is the so-called pulsar. A pulsar is an object that is observed to put out pulses, both of light and radio activity, RF, and the RF spectrum. And those pulses are extremely rapid. They are something like milliseconds apart. So it's like a extremely fast strobe light. And thinking of a strobe light, astronomers immediately leapt to the lighthouse kind of analogy. Something that must be spinning around, the beam is going around, and it's going around so quickly that this thing goes flash, flash, flash. Well, once the repetition rate of the pulsars was observed to get up to in the millisecond range, that meant that this star that was putting out this beam of radiation would have had to be rotating at 300 times a second. And 300 times a second is, well, we're talking about the speed of a dentist drill. So the astronomers decided, well, normal stars couldn't possibly rotate at that speed, and so they postulated the existence of what they called a neutron star. A neutron star is a star that is so dense that it holds together so well that it can indeed rotate at the speed of a dentist's drill. Well, the problem is that in nuclear chemistry, we know that you can't pack neutrons together that densely. They will all fly apart instantaneously. There's a principle called the island of stability in nuclear chemistry that absolutely prevents that. So here again we have the standard astronomers or astrophysicists going directly against another well-developed science. In the electrical model, however, there's a very simple explanation for pulsars. Everybody is familiar with the idea that the pulses can travel back and forth on electrical transmission lines. Such uncontrolled pulses, for example, were responsible for the famous Northeast blackouts. A similar effect can can occur between two binary stars connected by a plasma. The two binary stars act like capacitors that store charge. And if you reduce that in size to something you can produce